Okay, this is math lesson 5.4. We are on workbook page 299 to pages 302. So if you'll take out your math workbook and open it to page 299. We're going to be talking about factors and multiples today. Just do a real quick factor. If we want to review on factors, the factors of 4, we could make a factor rainbow. 1 and 4, and then 2 multiplies by 2. Those are the factors of 4. And if we want to do the multiples of 4, let's say we wanted to list the first 6 multiples of 4. 1, 2, 3, 4, 5, 6. So then we could sing our 4 song. 4, 8, 12, 16, 20, 24. And that would be the first 6 multiples of 4. So that's the difference between factors and multiples. Just a little review there. So our first problem says toy animals are sold in sets of 3, 5, 10, and 12. Mason wants to make a display with 3 animals in each row. Which sets could he buy if he wants to display all the animals? Well, first over here they ask us how many animals will be in each row. It says 3 animals in each row. Okay. How many animals are sold in each set? So they're in sets of 3, 5, 10, and 12. The product of 2 numbers is a multiple of each number. Factors and multiples are related. So first we could find the factors. Is 3 a factor of 3? Yes. 3 is divisible by 3. Is 3 a factor of 5? If we did a factor rainbow with 5, 3 would not be a factor. Is 3 a factor of 10? No. 3 is not divisible, or 10 is not divisible by 3. If we did a factor rainbow with 10, 3 would not be in that factor rainbow. Is 3 a factor of 12? Yes. 12 is divisible by 3. 3 is a factor of 3 and 12. Okay. Another way to do this is to make a list. So we could count by 3s. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. Okay. So then 3 and 12 are multiples of 3. So Mason could buy sets of 3 and 12 toy animals. Okay, let's go to page 300. All right, this one you really have to look at the picture here. What we're finding is common multiples, is a multiple of 2 or more numbers. So what we're going to be doing is we were finding common factors, now we're finding common multiples. Tony works every 3 days and Amanda works every 5 days. If Tony works June 3rd and Amanda works June 5th, on what days in June will they work together? Circle the multiples of 3 and draw a box around multiples of 5. So Tony is going to be our 3s, and Amanda is going to be, Amanda works every 5 days, so she's going to be our box here. So let's start with Tony. And Tony is the circle. He works every 3 days. So we're going to start with Tony on June 3rd. And we're going to count by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And if you don't know how to count by threes that high, we could just go one, we've got 1, 2, 3, and then he works 2, 3, then he works. So you could count by threes like that. Okay, so then we've got Amanda, and Amanda works every 5 days, and she starts on June 5th. So we've got 5, 10, we're doing the multiples of 5, 5, 10, 15, 20, 25, and 30. So think about which ones of these do we have both, which dates do we have both a circle and a square? Well, that's on the 15th and the 30th. So Tony and Amanda will work together on June 15th and June 30th. Okay. Multiply to list the next 5 multiples of 4. Now, I taught you about multiples before. It's a way we can sing our 4s, and that's the way we can list our first 5 multiples of 4. 4, 8, 12, 16, 20, 24. Bam, we're done. Okay, so now be very careful on the wording down here. This one is asking about factors, and this one is asking about multiples. So on number 2 here, is the number a factor of 6? If I were going to draw a factor rainbow of 6, would 3 be in the factor rainbow? Yes, because we do 1 and 6. We've got 2 and 3, and we see that 3 is a factor of 6. So yes. Is 6 a factor of 6? Yes. Is 16 a factor of 6? No, I don't see 16 anywhere in my factor rainbow. Is 18 a factor of 6? No. We don't see 18 anywhere here. Now, is this number a multiple of 6? Well, let's just do some multiples of 6 here. 6, 12, 18, 24, 30, 36, 42, and so on. Okay? Remember when we do the turtle song and we're dancing to the music, and we say the multiples of 6. So, is 3 a multiple of 6? No. Is 6 a multiple of 6? Yes. Is 16 a multiple of 6? No, I don't see 16 in that list. Is 18 a multiple of 6? Yes. So that's not so hard. You just have to keep track. Are they asking, is it a factor? And think of a factor rainbow. Or is it a multiple? And that's when we're counting by that number. Okay, now let's go to page 301. I'd actually like you to pause the video and go ahead and try 10 through 13. And then come back and see if you did it right. All right, so number 10, they're asking, is the number a multiple of 3? So if we were doing, say, the first 12 multiples of 3, let's go ahead, count by threes. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. I could go 3 more and make 39. Okay, those are multiples of 3. Is 4 in that list? No. Is 8 on that list? No. Is 24 on that list? Yes. Is 38 in this list? No. Okay, number 14. List the next 9 multiples of each number and then find the common multiples. Okay, in order for me to remember if I've done all 9, it says the next 9 multiples. So I put 9 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I know that I've done all they wanted me to do. So we're counting by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. Then we want the multiples of 8. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. 4 times 8 is 32. 5 times 8 is 40. 6 times 8 did just great with the number 48. 7 times 8 likes to mix with the number 56. 8 times 8 went to the store to get a Nintendo 64. 9 times 8 is 72. And 10 times 8 is 80. So then they want us to find the common multiples. Looking at this list, which ones do they have in common? Well, here I see an 8, and here I see an 8. So they have 8 in common. Let's see what else we see that's alike. Oh, I see a 16 here, and I see a 16 here. So our common multiples are 8 and 16. It's a lot of work, but we can do it. Okay, find the unknown number. Here I need to figure out what are they counting by. 12, 24, 36. If I do 12 plus 12, do I get 24? Yes. If I do another 12, do I get 36? Yes. So they are counting by 12s. If you know your 12s, 4 times 12 would be 48. Here, I want you to kind of think about money. They're counting by quarters. If I have 1 quarter, I have 25 cents. 2 quarters would be 50 cents. 3 quarters would be 75 cents. 4 quarters are $1. 5 quarters would be $1.25. All right, this next section gets pretty complicated here. Tell whether 20 is a factor or a multiple of the number. Write factor, multiple, or neither. Okay, so if I have 10, is 20 a factor of 10? So if I did a factor rainbow of 10, would 20 be in it? No. But if I counted, doing a multiple of 10, would I get 20? Yes. So 10 is a multiple of 20. Okay. Is 20 a factor of 20? Well, if I did a factor rainbow of 20, yes, 20 would be in there. So it is a factor. If I was counting by 20s, would I have 20 there? Yes. So it's also a multiple. 30. If I did a factor rainbow of 20, would 30 be there? No. If I counted by 20s, would 30 be in that lineup? No. So 30 is neither. Write true or false and explain. Every whole number is a multiple of 1. That is true, because n times 1 is equal to n. So every number, if we multiply by 1, we would get n. Every whole number is a factor of 1. That is false, because if I did 1 here, the only thing I'm going to get is 1. 2 would not be a factor of 1. Okay, let's go to the bottom one. Julio wears a blue shirt every 3 days. Larry wears a blue shirt every 4 days. On April 12th, both Julio and Larry wore a blue shirt. What is the next date they will both wear a blue shirt? Okay, so I'm going to make Julio the square, or the circle, and I'm going to make Larry the square. So Julio is a blue shirt on the 12th, and Larry is a blue shirt, I'll use a different pencil here, on the 12th. So they want to know what's the next day they're both going to wear a blue shirt. So Julio is every 3 days, so 12, 15, 18, 21, 24, 27, and 30. Okay, that's Julio. Now Larry is every 4 days. So these are like counting by 4. So 12, 16, 20, 24, 28, and I don't have a 32. So which one of those dates did they both wear a blue shirt? That would be the 24th. So the answer is April 24th. Okay, our last page here, page 302. We're going to skip the first 3 problems and go down here to number 26. Kia paid $10 for 2 charms. The price of each charm was a multiple of 2. What are the possible prices of the charms? Okay, so let's do the multiples of 2, 2, 4, 6, 8, and 10. Okay, and the 2 numbers have to add up to $10. So can you look at this list of numbers and pick out 2 that are going to add up to 10? You might say 4 plus 6 is equal to 10. Another one might be 8 plus 2 more would equal 10. All right, number 27. The answer is 9, 18, 27, 36, and 45. What is the question? Okay, those kind of sound like multiples. What are they counting by? The answer 9, add some more, and you would get to 18. They are counting by 9s. So we could say, what are the first 5 multiples of 9, with a question mark behind it, because it says, what is the question? Okay, how do you know whether a number is a multiple of another number? If it is divisible by the number. Okay, select true or false for each statement. The number 45 is a multiple of 9. Okay, remember multiples are counting by that number. So if I was counting by 9s, would I get to 45? Yes. Because 5 times 9 is 45. The number 4 is a multiple of 16. If I'm counting by 16s, am I ever going to get 4? No, because you're starting with 16. The next one would be 32. 28 is a multiple of 4. If I was counting by 4s, would I get to 28? Well, let's just sing that. 4, 8, 12, 16, 20, 24, 28. Yes, I did get to 28, so that one is true. The number 4 is a factor of 28. If I did a factor rainbow of 28, could I take 4 and multiply something by it to get 28? Yes, 4 times 7 is 28. The number 32 is a factor of 8. If I did a factor rainbow of 8, could I multiply 32 by something and get 8? No, I could not. So that is false. All right. Now you're going to finish this lesson. Look on your lesson plan to see what you do next.